So good day, everyone. We are going to talk about destructive inspection methods. Next slide. So first, what is destructive inspection methods? Destructive testing is used in aerospace to determine the physical properties of materials, components, and assemblies. It can reveal useful information about characteristics of materials, including ductility, tensile strength, and fracture toughness. Destructive testing is a type of evaluation that determines how a component will behave under pressure until it fails. So next slide. Another meaning of destructive inspection method is that it can identify physical properties of a component like toughness, hardness, flexibility, and strength. Destructive methods, test, destructive testing methods are commonly used for failure analysis, process validation, materials, characterization, and conform a key part of engineering critical assessments, which also involves non-destructive testing techniques, such as digital radiography. Next slide.
So the first the first step in destructive inspection method is sample selection. In sample selection, we identify and select and the test specimens that represent the material or component you want to evaluate. Ensure that the specimens are prepared in a way that they are representative of the actual material or component. The next step is sample preparation. Prepare the selected specimens by cutting, machining, or otherwise modifying them to the required size and shape for testing. Ensure that the preparation process does not introduce any defects or alter the material's property significantly.
So for the marking and documentation, this is where the procedure where we clearly mark each specimen with the essential information such as its source, date of manufacture, and any of the other relevant details that are needed for the specimen. This documentation is crucial for the traceability and record keeping. Next. For testing procedure, this is where we conduct the destructive testing according to the specific method where the mechanics or the technicians are using. The exact procedure will depend on the type of test, but there are 6 common destructive test methods that are to be discussed. For the first one is tensile strength. For tensile strength, this is where the specimen or they measure a material's mechanical properties, like its tensile strength, yield strength, and elongation. They subject the specimen to axial tension until it fractures. For Charpy impact testing, this is where they measure a material's toughness and resistance to impact, where they do it by loading and by striking a notched specimen with a swinging pendulum. Next. For the hardest testing, there are various methods like Rockwell, Brinell, or Vickers. These are used to determine a material's hardness by pressing a hard indenter into the specimen's surface and checking whether it will make a dent. For bend testing, this is where they evaluate the ductility or the bending ability of the specimen and the soundness of a material by bending it to a specific angle until it fractures. For metallography, this is where they involve the preparation of thin sections of the specimen, where it is followed through a microscopic examination to assess the microstructure, the grain size, and any defects that are needed to be seen at a microscopic level. For the corrosion testing, this is where they do an immersion of salt spray or other methods that are used to evaluate the specimen's resistance to corrosion.
Next, we have our data collection. Data collection is the record the relevant data during the testing process. This data may include force displacement curves, fracture characteristics, hardness values, or any other
pertinent information. Step 6 is analysis. It interprets the test results to draw conclusions about the material's properties, structural integrity, and performance characteristics. It compared the results to establish standards or specifications if applicable.
So for the reporting, this is where they prepare a comprehensive report where they summarize the destructive inspection, including the test methodology, results, conclusions, or recommendations. In the report, this is where they typically share the relevant stakeholders or quality control personnel on what they took upon the specimen. Next. And lastly, disposal. This is where they properly dispose of the tested specimen as they are no longer suitable for use or retesting. Next. So aside from the steps that destructive testing methods are used, now we will discuss the most common destructive testing methods that are used in the aviation industry.
For the most common destructive testing method, first is the corrosion testing. So it's a test method done to test the effectiveness of applied corrosion-resistant measures. Second is the hardness testing, which the material hardness determines whether the components undergo permanent deformation due to stress. Next is tensile elongation testing, which is conducted by applying a controlled force across test material till it fails, crack, breakage, or etc.
So for the fourth common destructive testing method is torsion testing. It's conducted similarly to tensile testing. Instead of compression and elongation, torsional forces are applied to the material. Next slide. Next, stress testing focuses on the forces that are anticipated to happen during regular operations. Sixth, aggressive environment. Materials are tested based on the characteristics of the environment they will be operating in.
Next is residual stress. It is a measure that determines if a component can withstand extreme load and stress conditions during its service life. Last is shear testing. Shear testing differs from tensile and compression testing in that the applied forces are parallel to the object's upper and lower faces. Shear materials behave differently from tension or compression materials, resulting in different strength and stiffness values. Shear testing involves applying a lateral shear force to a specimen until it fails.
Now, having all of that heard, we have heard the steps in the destructive inspection method and the common methods that are used in that method. We are now going to discuss the advantages and disadvantages of it. For the advantages, it has been seen to be a research and development where they can truly understand a specimen's capabilities towards the aviation industry. It also has an accurate failure analysis, making sure that every specimen reaches its full limits or extension maximum limits in understanding whether it can perform its purpose and understood through the quantitative data from the record keeping. The disadvantages of the destructive inspection method is that there are resource waste upon the disposal of all of it, high expenses due to the resource that is being used, and the time requirements needed to be done for every and all the testing methods that are needed to be done. Thank you, and that will be for our topic for the destructive inspection method.